All right, let's take a look here at problem number 10. If you notice where this vertex is located, it's inside the circle, but not at the center. So going back to that little cheat sheet that we created before we were out of school, that angle is going to be equal to, in this case, when it's inside and not at the center, I'm going to add this 122, and then I'm going to add it to this value right here, which is the x. All right, so I'm going to have 122 plus x. That's going to be divided by 2. Now, if you remember, you could go a couple different ways with this if you want. I always like to get rid of that 2. So I'm going to do a little multiplication here. So this 2 and this 2 are going to divide themselves out. And then I'm going to double the 86 on this side, multiplying this both sides by 2 there. All right, so just a little reminder on why I'm doing that step. 86 times 2 is 172. All right, so here's 172 is equal to 122 plus x. So that means all I have left to do is subtract and move this 122 to the other side. So for the sake of sparing you looking at some poorly written numbers again, I'm just going to talk you through it. 172 minus 122 on the calculator there should give you 50 degrees. All right, so we're left with 50. That might be the best 5 that I've done up to that point. So 50 degrees. So then I could come back up here. Since that already looks like a 0, I'm going to make that a 50. We'll call that 50 degrees. So we're asking for that arc measure right there. Number 11, moving over here, vertex is outside of the circle. So if it's outside, I'm going to be subtracting 145. 145 minus x. I'm just going to treat that as an x. That's going to be equal to 50 in this case. So 50 is equal to 145. Remember, that's that larger arc minus the smaller intercepted arc. So larger, and there's the smaller. So minus x divided by 2. Pretty easy to double that. That's 100 is equal to 145. And then remember, it's minus x, and it's minus because that vertex is on the outside. So I'm doing a subtraction. Okay, that's the difference between problem 10 and 11. 10 was on the inside, not at the center, so it's an addition up there. Now when I subtract, I'm going to end up with negative 45 is equal to negative x, and that's all right. So think of it as divide this side and this side both by a negative 1, or do the opposite, which leaves you with 45 is going to be equal to positive x. All right, so there's my value that I've come up with. That makes this arc in here that we were trying to find. It's going to make this 45 degrees. This is a 45-degree arc right along here. Okay, and then remember, you could do 145, sorry, minus 45, that's 100, and 100 divided by 2 is 50. All right, so remember, you can always go back through and kind of check your work as you're going. All right, I'll apologize in advance because with all the algebra going on with this, it might be a little difficult to watch, but I'll do the best I can for you. All right, this vertex is located outside of the circle. So that means we're going to have to do a subtraction. So what I'm looking at right here is something like 70 is equal, larger arc, okay, is going to go all the way around to here. And that's going to be the 66, try to get a couple sixes there, 66x minus 3. But then it has to be a minus 55. So I'm also taking away 55, and then that's going to be divided by 2. So first thing, I'm going to get rid of that 2 by multiplying both sides by 2. I showed that in the other problem, so I'm just going to talk you through it here. So that's where I'm getting that 140. Started by multiply this side by 2 and this side by 2. That gets rid of that 2 in the denominator. So now what I'm really looking at is 66x. All right, 66x minus 58. I'm not sure where I'm going as I'm writing this. For some reason, I'm getting out of control. All right, so now I'm going to add 58 to both sides. So that's going to give me, 198, I believe. So 198 is going to be equal to 66x. And then on the calculator there, if you're not sure, if that's not a mental math problem that you're used to encountering, 198 divided by 66 works out kind of nice for us. Gives us an x value that is equal to 3. All right, now if you're looking to check your work, take the 3, I'd plug it in right out here. So 66 times 3 gives you 198 minus 3 is 195. All right, so this 195 minus this 55 is 140, and then 140 divided by 2, or half of 140, is 70, and that's exactly what it should be. So that checks out really nicely for us. All right, let's look at 13. Vertex is inside the circle, but it's not at the center. So that means 18x minus 2 will be equal, I'm going to have to add this, 80 and 168. So add them together because it's inside and not at the center. So 80 plus 1, I'll try to sneak that in there, 168. All right, and then remember that's going to be divided by 2. All right, so looking at, I'd probably just leave this as an 18x minus 2 on this problem. You could double it if you want. Just make sure that if you do, you end up here looking at 36. Oops, I forgot the x. Make sure if you do double it to get rid of that 2, make sure you got 36x minus 4. All right, but the reason I'm not going to is because on my calculator I can type in 80 plus 168 and get 248 divided by 2. So on my calculator, if I type that all in, I can get 124 and simplify that pretty quickly. All right, then I'm going to add 2. That gives me 18x is going to be equal to 126. And then I'm going to divide both sides by 18. So 126 divided by 18, I believe, gives us 7. And once again, if you wanted to plug that in there, that 168 plus 80 divided by 2, so when I add those two arcs, I should get 124. 18 times 7 is 126 minus 2 does give us 124, so we see that that checks out as well. All right, here we go. Number 14, a little Pythagorean theorem. If you remember, a tangent and a radius, or a tangent and a diameter. So here's the diameter, here's the tangent, always intersect to form a right angle. So at this location right here, that's 90 degrees. So that's going to give me the setup of something like 4.5 squared plus, okay, you can handle this a couple different ways. This is one of the legs, right? This is your hypotenuse, so you know that that automatically, right, automatically has to be equal to 7.5 squared. We know that has to be the case. Okay, so how you handle this really just kind of depends on, what you want to think of it as. If you want to think of it as x, okay, and then this is also x, right, because that was the radius, so now the diameter, they'd have to be the exact same, so it's going to be, you can think of it as 2x when I add it together, so I can think of that as 2x quantity squared. That would be fine. All right, so what I'm going to do here is go with 4.5 squared, which is 20.25, so I've got 20.25 And then what? This is going to be plus 4x squared. I probably should have had parentheses around this to begin with because it's really like having 2x times 2x. So it's going to be a 4x squared. And then 7.5 quantity squared. 7.5 quantity squared is 56.25. So 56.25. Move the 20.25 over, so you're looking at 4x squared 56.25 minus 20.25 gives us 36. And 36 divided by 4 gives me x squared is equal to 9. And then if I take the square root of both sides, I'd be looking at something like x is equal to 3. All right, x is equal to 3. All right, I do want to show you a second approach that you could take. If you wanted to, instead of using x, you could maybe think of this whole side as being y. So your setup is going to be similar, but a little slight variation on it. 4.5 squared plus y squared is going to be equal to 7.5 squared. Okay, so then what you're looking at is once you get to 20.25, okay, and I'll try to scribble that in here for you, 20.25 plus y squared. It's going to be equal to, we said this was 56.25, correct? All right, so now when I do that subtraction, what I'm looking at is, I think y squared is equal to what did we say this was, 36. All right, and then when I take the square root of both sides, I'm going to have y is equal to 6. Now, that is not my final answer. That's the total distance. All right, so if the whole diameter was equal to 6, then that means that each one of these radii have to be equal to 3, because 3 plus 3 is going to be 6. And remember, this was the piece that they asked us to find. So kind of giving you two approaches. 6, I'll just jot that in over here. 6 split into 2 equal parts ends up with a value of 3, which does get us back to what we needed to find, which was that one length of the radius.